Hi friends, good evening to everyone. Welcome back to my channel, Belagali's class. Belagali's class. My friends, I have started a circle for the 10th standard students, SSLC bar 10th standard students. I have started with a circle. In the first video, I have done almost all the basics connected with the circle, and one theorem I have done, theorem number 1 I have done in the first video. Now in this class I am going to do another theorem number 2. There are only two theorems. Theorem number 1 I have already done. This is theorem number 2, my friends, theorem number 2. Before doing that theorem number 2, just to concentrate on this note. From the point outside the circle, two tangents can be drawn to the circle. PQ, PR are the tangents from outside point P here. My friends, this is the point which lies outside the circle. From this external point, you can draw two tangents to the circle. What they are? One is PQ, another is PR. This PQ denotes what? Length of the tangent drawn from the external point to the circle. That PQ denotes length of the tangent from the outside point P to the circle, my friends. Yes, remember, from a point which is outside the circle, we can draw two tangents to the circle. One tangent is at Q, another tangent is at R. PQ and PR are the two tangents to the circle. This PQ and PR, they are also called as what? Length of the tangents. Yes, my friends. This is one note. This is theorem number 2, my friends. This is theorem number 2. Very important theorem, my friends. This is very important theorem. Among the two theorems, my friends, theorem number 1, theorem number 2, normally they give what to the board exam, either theorem number 1, otherwise theorem number 2. But chance of getting in the exam is what? Theorem number 2, my friends. What is this theorem number 2? Prove that the lengths of the tangents drawn from the external point. What do you mean by external point? A point which lies outside the circle. External point to the circle are equal. Length of tangents drawn from the external point to the circle, those length of tangents are equal. My friends, this is the figure. It is a given circle with a center O. P is the external point. PQ and PR are the tangents to the circle. See, given a circle with center at O, P be the external point, PQ, PR are the tangents drawn from the P to the circle. Join OP, OQ, OR. This is, my friends, reference figure is this. We want to prove length of tangent PQ equal to length of the tangent PR. That is, PQ equal to PR, or length of tangent PQ equal to length of tangent PR. We want to prove this. My friends, proof. In triangles OPQ and OPR, OPQ, this triangle, my friends, and OPR, this is another triangle. From these two triangles, yes, what is the first observation? First observation is, see, This is radius, this is what? Tangent. And radius is perpendicular to the tangent, my friends. This is theorem number 1. This is theorem number 1. What is it? Radius of the circle. Radius of the circle is perpendicular to tangent. Tangent at the point of contact. Tangent. Therefore, OP is perpendicular. OQ is perpendicular to PQ. I have written here. OQ is perpendicular to PQ because of theorem number 1. And OR is perpendicular to PR. When these are perpendicular here, angle here is 90 degrees, angle here is 90 degrees. Then they are equal. From these two triangles, my friend, triangle OQP is equal to angle ORP. I have written here. Angle OQP equal to angle ORP. Both are equal to 90 degrees because of this reason. What is that reason? Radius is perpendicular to tangent by theorem number 1. And this side OP, this side OP is common to both the triangles. It is common to both the triangles. OP equal to OP. It is a common side of both the triangles. Then what is one more condition? This OQ. OQ equal to OR. What is it? OQ and OR, they are the radii. Radius of the circle. Therefore, it is equal. Therefore, OQ equal to OR. Radius of the circle. Radius of the circle. Therefore, by RHS criteria, what is RHS? Right angle, hypotenuse, one side. Right angle, hypotenuse, one side. By RHS criteria, these two triangles are similar, or you can say they are congruent. These two triangles are congruent. When the two triangles are congruent, corresponding sides and angles are equal. Therefore, what is the corresponding side here? Is PQ equal to PR. Corresponding side PQ equal to PR. Finished. PQ equal to PR. That implies lengths of the tangents drawn from the point P to the circle are equal. These are length of the tangents. Finished. This is the proof of the theorem. Very simple. Appeared many times in the question paper, my friends. Many times in the question paper. Yes, I will explain once again. Prove that the lengths of tangents drawn from the external point to the circle are equal. Those lengths are equal. Data. Given a circle with center at O, P is the external point. PQ and PR are the tangents drawn from P to the circle. Yes, this is the figure, my friends. Join OP, OQ, OR. Now we want to prove length of the tangent PQ equal to PR. To prove this, in the triangle, it is proof, my friend. In triangles OPQ and OPR, we have these two angles are equal. Angle OQP equal to angle ORP, both are equal to 90 degrees because of this reason. This is the common side, OP is the common side, and OQ equal to OR because radius of the circle. Then right angle, hypotenuse, this is what? One side of both the triangles are equal means by RHS criteria, these two triangles are congruent. When the two triangles are congruent, corresponding sides are equal. Therefore, PQ equal to PR. PQ equal to PR. What is that PQ and PR? They are nothing but lengths of tangents drawn from the point P to the circle are equal. This is our theorem. Note, my friends, when these two are congruent, these two angles are equal. When these two are congruent, these two angles are equal. Yes, what is this angle? Angle OPQ equal to angle OPR. Then this OP bisects this angle. This OP bisects angle, my friend QPR. OP bisects angle QPR. In other words, what is this O? This O is the center of the circle. Then center of the circle lies on the bisector of the angle QPR. Lies on the bisector of the angle QPR. This is additional. My friends, we use this result in 2-3 examples. 2-3 examples. What is that? This OP bisects this angle. These two angles are equal. What is this angle? This is the angle made by the tangents. Angle made by the tangents. This line which joins center with the external point. This line bisects the angle made by the tangents. Bisects angle made by the tangents. That result we use while doing the examples. Yes, my friends. This is the theorem number 2, which is a very, very important theorem, my friends. There are 2 theorems. One, radius perpendicular to the tangent. Another, length of the tangents drawn from the external point. Those lengths are equal. Among these 2 theorems, my friends, normally they ask for one theorem. One theorem. More times this theorem number 2 is appeared. This also appeared in question paper. Anyway, both are very important theorems. You have to prepare them. Right, 1 minute time, copy it. 1 minute time. Yes, my friends. Quick. Yes. Now I do the examples from the exercise 4.1. 4.1 means they are the examples based on theorem number 1. They are the examples based on theorem number 1. Exercise 4.2. They are the examples based on theorem number 2. What is that? Length of the tangents drawn from the outside point to the circle are equal. Are equal. Yes, friends. Remember this. I just, in a simple way, I write this as a note. This is the circle. This is the circle. Center of the circle. This is the external point P. From P, there is one tangent. This is, my friends, Q. This is center O. This is perpendicular here. Center O. So in this case, my friends, OQ is perpendicular to PQ. First, theorem number 1 it is. OQ is perpendicular to PQ. Theorem 1. Theorem 1. Then there is a second tangent from P. Here it is. Then this point, this is R. This is OP. So in this case, second theorem, you have, my friends, PQ equal to PQ. Theorem number 1, OQ perpendicular to PQ. This is theorem number 1. Next, PQ equal to PR. This is theorem number 2. And what is another? OP bisects, or you can say angle OPQ equal to angle OPR, bisection. My friend, this is theorem number 1 and theorem number 2. This is theorem 1, theorem 2, my friends. Remember, it is there always. Till I complete the examples. Yes, friends. This is exercise 4.1, circle. This is exercise 4.1. This is chapter 4 actually. This circle is a chapter 4. Yes. First example. These are 1-mark questions. First example. This is based on first theorem, my friends. How many tangents can circle have? Yes, my friends. This is the circle. This is one point. At one point, we can draw only one tangent. At one point, one tangent can be drawn. At one point, on the circle, one tangent can be drawn. One tangent can be drawn. Then how many points are there on the circle? Since there are infinite number of points, on the circle, so there are infinite number of tangents. Number of tangents to the circle. Then what is the answer, my friend? How many tangents can be drawn? A number of tangents to the circle. This is circle. At one point you can draw one tangent. Then how many points are there on the circle? There are infinite number of points. Therefore there exists what? Infinite number of tangents to the circle. So what is your answer? This, my friend. Infinite number of tangents. Infinite number of tangents to the circle. Yes, my friend. This is one more question. Second example. Second. Fill in the blank. Blank spaces, blanks. Yes, in this first example. Yes, a tangent to a circle, a tangent to a circle, intersect the circle at dash points. At the dash point, a tangent to the circle intersect the circle at a number of points at a dash point. My friends, this is the tangent. Then this tangent to the circle intersect the circle at one point. Intersect the circle, what is the answer? At one point. At one point is the answer. This is the answer, my friends. At one point. Second question in this too. A line intersecting a circle at 2 points. At 2 points. At 2 points is called dash. A line intersecting a circle at 2 points. My friends, this is the circle. This is your line which intersects at 2 points. PQ, center. This is what? MN or AB, whatever it is. Then what is that? PQ. PQ is known as secant of the circle. It is called secant. Secant of the circle. The same question in 2019, my friends. 2019 March, under one mark question, it is appeared like this. A straight line, question it is, straight line under 1 mark. A straight line which passes through passes through 2 points. 2 points on a circle. On a circle is A. Option A. This is a chord. Option B. A secant. Option C. The radius. Option D. A tangent. Yes, my friends, it is appeared in 2019 question paper. A straight line which passes through the 2 points. It is a straight line which passes through the 2 points is called, on a circle is known as, what is this, my friends? Secant of the circle. Then what is the answer? Answer is B. Answer is B, my friends, which is secant. These questions, man. This, what is this? It passes through 1 point. 1 point, when it is called as what? Tangent, my friend. Tangent. Like this. They will ask these questions. Yes. Third example. A circle can have dash parallel tangents. At the most. Yes, my friend. This is the circle. At the most, parallel lines means what? It has what? 2 parallel tangents. This is one, this is another. This is the diameter of the circle. At most, you have 2 tangents. Yes, my friends. How many? Answer is 2 tangents. At the most, 2 parallel tangents. This is third example. Fourth is all these 5 examples comes under 1 mark question. Exercise 4.1. Yes, now that fourth example. The common point of a tangent to a circle and the circle is called dash. Read it. The common point of a tangent. Yes, my friends, what is this P? P is a common point on the tangent as well as on the circle. What you wanted? The common point of a tangent to a circle as well as the circle. It is a common point on the tangent as well as on the circle. This point is called as point of contact. Answer is what? Point of contact. Answer is point of contact. Point of contact. Yes, my friend. This is the answer. This comes under 1 mark questions. 1 mark questions. One more, this fifth is from the external points, outside points, from the external point only dash dash tangents can be drawn. Tangents can be drawn to the circle. Drawn to the circle. How many? Yes, just shown in the corner only 2 tangents, my friends. Only 2 tangents can be drawn. 2 tangents can be drawn. These are just 1 mark questions, my friends. 1 mark questions. Yes. Next example is, it comes under 2 mark question. Next example. Comes under 2 mark question. This is in 2, these are the examples. This is third one. Third example. A tangent PQ at a point P of a circle of radius 5 centimeters meets a line through the center O at a point Q so that OQ equal to 12 centimeters. Then length PQ equal to dash. These are the options, my friends. Yes. First option A, 12 centimeter. B, 13 centimeter. C, 8.5 centimeter. D, square root 119 centimeter. These are 4 options, my friends. 4 options. This comes under 2 mark question. Yes. Read it. A tangent PQ. Tangent is here. Tangent at the point PQ. This is the external point. This is point Q. This is center of the circle O. Then radius is given. Radius of the circle. What is radius? Is 5 centimeter. This is 5 centimeter. meets a line through the center O at the point Q from here to here. This is given as OQ is given as 12 centimeter. You wanted to find what is PQ. What is PQ? Yes. This is Q. Yes, this is the figure, my friend. OP is given 5 centimeter. OQ is given, OQ is 12 centimeter. You want to find the PQ. Find the PQ. Yes, my friends. We know that radius is perpendicular to tangent. Radius at a point is perpendicular to tangent. Tangent at P. Therefore, that is OP is perpendicular to PQ. Therefore, my friends, triangle OPQ is a right-angled triangle. Right-angled triangle. Here 90 degrees, my friends. 90 degrees. When it is a 90 degrees means what? This triangle is a right-angled triangle. Then by Pythagoras theorem, yes, this OQ square equal to OP square plus PQ square. What is OQ? 12. 12 square equal to OP square. What is OP? 5. 5 square plus PQ square. Therefore, PQ square equal to PQ square is 12 square minus 5 square. You can apply what? A square minus B square. 12 minus 5. 12 minus 5 into 12 plus 5. What is this? This is 7 into 17. 17 into 7 is 1119. Therefore, what is PQ, my friend? It is square root of 119 centimeters. PQ is this. Otherwise, you can go here itself. What is this? This is 144 minus 25. 144 minus 25 is 119. Otherwise, if you want to do right directly this. So the answer is 119. 1 minute, my friends. Tell. Yes. A tangent PQ at the point P of a circle of radius 5 centimeter meets a line. This is a line at the point Q. Yes. So that OQ is given as 12. Then you want to find what is PQ. Find PQ. Length PQ equal to dash. These are 4 options. Yes. Given OP. Geometry means we need figures, my friends. OP. OQ. Find PQ. Yes. Radius is perpendicular to the tangent. So OP is perpendicular to PQ. It is a right-angled triangle. Right-angled triangle means the great friend, Pythagoras theorem. Hypotenuse. OQ square equal to OP square plus PQ square. Given 12 square, given 5 square plus PQ square. Otherwise, you write 144 minus 25 is what? 119. What is PQ? 11 square root of 119 centimeters. My friends, these 3 examples are from what? Exercise 4.1. Exercise 4.1. These are the given examples in the textbook. Next, I want to do some examples from exercise 4.2. Exercise 4.2. Yes, my friends. First example. Yes. The first example is 4.2. First example. From a point Q, from a point Q, the length of the tangent Q length of the tangent to the circle is 24 centimeter, and the distance Q, now I will remove it. Yes, 24 centimeter. And the distance of Q, point Q, from the center is 25 centimeter. Then the radius of the circle, is a dash. These are the options. A, 7 centimeter. B, 12 centimeter. C, 15 centimeter. D, 24.5 centimeter. These are the options. Yes, first you have to draw the figure, my friends. Figure. Yes, circle. From a point Q that is outside, the length of the tangent to the circle is, this is circle. This is the point Q. The tangent is drawn. The length of the tangent is drawn from the point Q. This is the tangent is at the point P. Now the distance of Q from the center here, center of the circle. This is radius of the circle, which is perpendicular here. This is the distance of Q from the center. This is given as 25. This is given as 24 centimeter. This is 25 centimeter. You wanted what is the radius of the circle? OP. What is the radius of the circle? Yes, same thing. Again, Pythagoras theorem. Given, say, from Q, length of the tangent to the circle is 24. This is the length of the tangent to PQ. Given P2 is 24 centimeter. Next, length of distance of Q from the center, OQ. OQ is given as 25 centimeter. Then find the radius. Find radius OP. Find the radius OP. Again Pythagoras theorem. Again my friends, again what is that? First theorem, that is radius is perpendicular to tangent. Therefore, my friend, OP is perpendicular. OP is perpendicular to PQ. Implies which triangle? Triangle OPQ is a right angled triangle. Is a right angled triangle. Then by Pythagoras theorem, therefore by Pythagoras theorem, you have OQ square hypotenuse equal to OP square plus PQ square. By Pythagoras theorem, 90 here, this is hypotenuse. OQ square equal to OP square plus PQ square. Put the values. OP square is 25 whole square equal to OP square we want to find plus PQ square is what? 24 the whole square, PQ. This is OQ 25, PQ is 24. Then from this, OP square equal to 25 the square minus 24 the square. A square minus B square. A minus B into A plus B, 25 plus 24. My friend, this is 1 into this is 49. This is 1, this is 49. Therefore, OP square equal to 49. 49 is nothing but 7 square. So, OP equal to 7. Therefore, radius of the circle is 7 centimeters. Radius of the circle is 7 centimeters. These are either 2 mark, otherwise 3 mark questions. A good example, my friend. It is also a good example. Copy it. Copy it. 1 minute. Copy it. Yes. Yes. Yes, my friends. Then there is one example from the question paper. Question paper. Yes. The length of tangent, it is from the question paper. Yes, I write here, then I will cancel this. Otherwise, I have to write here. This you do it yourselves. Do it yourselves. Yes. Now the length of tangent from the point A at a distance, this point A, at a distance 5 centimeter, 5 centimeter from center of a circle. Center of a circle. is 4 centimeter. 4 centimeter. Find the radius of the circle. Radius of the circle. Same question. The only these numbers are different. DIY. Yes. What is given? The length of tangent from the point A at a distance from the point A is at a distance. Point A is at a distance 5 centimeter from the center of a circle. This length of the tangent is 4 centimeter. This length of the tangent is 4 centimeter. You want to find what is the radius of the circle? What is the radius of the circle? 5, 4 means what? What is the radius? Radius is, my friend, 3, 5. Pythagorean numbers, again 90. Right angle triangle, yes, two sides are 4 and 5. Hypotenuse is 5. Then this side is what, my friend? 3 centimeter. Radius in this case is 3 centimeter. We can do it this way. This way. Yes, friends. Today this much is enough. These are the examples from exercise 4.2. 4.2. One example I have done. In the next class video, I do the remaining examples from exercise 4.2. My friends, remember, these are the two very important theorems. Only two theorems are there. Among the two theorems, almost, my friends, 100% to get one theorem. It is a good choice. Either 3-mark question, my friends. 2-mark is very rare. They give under what? 2-mark questions. Yes, my friends. This is enough today. Thank you, my friends. Thank you. Yes. Bye, goodbye. Namaste, namaskara, my friends. Namaste. Namashinya. Have a good day. Good day.